All right, so definition of a function does not have anything to do with what system you're working in. It's a function is always a set of ordered pairs, all right? And such that each second element has a unique first element. Yeah, because r is a function of theta. That's what keeps throwing me on this. We're used to seeing points x, y, and then y is a function of x. But we have the points r, theta, and then r is a function of theta, right? So usually it's going to be r is some function r of theta. So we'll see a couple examples, all right? Now, in rectangular coordinates, you have this nice thing that we have a vertical line test, because if every x has a unique y, then you could never draw a vertical line and hit the graph twice, okay? But the problem with polar coordinates is every point has multiple representations, so you could have every theta have a unique r, and yet there are points that sort of seem to land on top of each other because it's a different r and theta, but they end up describing the same point. All right, so let's just look at some specific examples. So I'm going to start with r equals theta over 2 pi. So if this was just y and x, right? Y equals x over 2 pi, you would just have a straight line with slope 1 over 2 pi. All right, so what are we going to get here? Think about ahead. What are you going to get for r equals theta over 2 pi? Well, so let's just look at these, and so we're going to do r equals theta over 2 pi. So let's start with 0. The point 0, 0 is going to be right there. And then let's just look at some different values for theta. So if I'm going to go around to, well, let's go to theta equals pi over 6. Then r is going to be pi over 6 over 2 pi is 1/12. So it's going to be like really tight into the center there. And if I do pi over 3, I'm going to do pi over 3 over 2 pi, so that's going to be 1/6. Right, so we're in really tight like that. Now, when I get to pi over 2, I'm going to have 1/4, so I'm going to be up to 1/4. And then, so let's go from there. So we have this idea that it's doing this. All right, let's go from there and start jumping up. We'll just go to pi. So pi over 2 is going to be 1/2. That's going to be there. So it's going like that. All right, you can see what's going to happen, right? Then 3 pi over 2 is going to be, well, you know, the pi and the 2 are going to cancel out, so you're going to have, well, the 2 is going to reinforce. So you're going to have 3/4 after the pi's cancel out. So you're going to be here, right? That's the point, right? So this is the point 3/4 3 pi over 2. And then when I get around to 0, again, so remember that 0 is coterminal with 2 pi. So this, I'm thinking of this angle as theta equals 0 to start, but it's also theta equals 2 pi. So when I do 2 pi over 2 pi, I get 1. So I'm back here, and I already have what looks like we're breaking, you know, if there was any kind of a radial line, law, or vertical line, there isn't. All right, there's just not. And then so what am I going to have up here? Well, this is 4 pi over 2, so this is going to be 5 pi over 2. Right, so thinking about your coterminal angles, this is 5 pi over 2. So when I put that over pi over 2, I'm going to have 5/4, which is 1 1/4. All right, so you can probably figure out the pattern. This is going to be 1 1/4, 1 1/2, 1 3/4, 2. Right? So then we get the idea that essentially, as the theta increases, r is increasing linearly with respect to theta, and that means that the r is just going to keep going out and out. So basically, it's going to describe a spiral that gets bigger by 1 unit of r every revolution. So it's a quarter unit every quarter revolution. Can I draw it? Not really. All right, and it just keeps doing that forever. So that's your basic spiral. All right, now let's look at a little bit more complicated one. So now what I want to look at is a function r equals 7 sine of 3 theta. All right. r equals 7 sine of 3 theta. Now, I want you to watch how I'm going to do this because I want you to do it. All right? So, we're going to start with sine. Do I want to make a table? I guess I don't need to make a table. So we're going to start with sine of 0 is 0. So I'm going to start again with 0, 0. Now what we're going to do for our pi increments is we're going to do our theta increments. I want to step every line that I have here. So what are these lines? I have pi over 6 divided into 4 pieces. So when I'm going to graph it using delta theta, okay, my change in theta is going to be pi over 24. So my next point here is going to be on this angle, and right, this is pi over 24. You don't have to label all these, but pi over 24. And so now I need to know 7 times sine of 3 times pi over 24. So that's sine of pi over 8, but I don't know that, right? So on this one, I'm just going to go ahead and do that on my calculator, but then we'll shortcut it on starting the next one. So if I go 7 sine of 3 times pi over 24 is pi over 8, pi over 8, all right, and I get 2.67. That's a surprisingly large number, I think. Makes me want to check to make sure I'm in radians, and I am. Okay, so 2.67, almost 3. When I'm on this first pi over 24, I'm almost at 3. 1, 2, 3, but it's 2.67, so probably right about there. All right, now in the next video, we'll set up a table and start really clocking through these quickly.